Hello friends, I welcome you in lecture number 9 on partial ordering. In this lecture also we will discuss one more question on hash diagram, and this question was asked in GTU Winter 2021 exam. First we see what is this question. Let capital A be the set of factors of a particular positive integer m and less than or equal to be the relation divides. That is, we have to consider all those ordered pairs xy where x and y are elements of set A and x divides y. That is, we are given the divides relation on the set A, which is the set of factors of a particular positive integer m. Draw hash diagrams for m equal to 45 and m equal to 210. In part A, we have to consider m equal to 45, that is our set will be the set of factors of 45, and in second part we have to consider set of factors of m equal to 210, and we have to draw the hash diagram for this set A with divides relation. Here the partial order relation given is divides relation. This is the notation for partial order relation, but here less than or equal to is nothing but divides relation. So first we consider m equal to 45 and then we will see for m equal to 210. So in part A I am taking m equal to 45 and given set is the set of factors of 45. So we have to write down all the factors of 45 in this set A, and we know that 1 is a factor of every positive integer, then 2 is not factor of 45, 3 is a factor of 45, then 5, 9 and 15 and 45. So we have all these factors of 45. If you cannot write directly, you can write in this way also. You can proceed by the method of finding factors. So here I obtain 15. 15 I can write as 5 into 3 into 3. So I obtain 5 also. Then this I can rewrite as 5 into 9. So I obtain 9 also. So I have written 3, 5, 9, 15, and you have to check if there is any other possibility. So here I have written all possible factors of 45, and we are given that we have to consider divides relation on this set A, and we know that divides relation is a partially ordered relation on this set of positive integers. Here we have finite number of positive integers. So this is a partially ordered set, and we have to draw the hash diagram for this partially ordered set. Now as we know, we have to represent each of the elements by small circles or dots, and circle for element x is drawn below the circle for element y if x is related to y and x is not equal to y. That is, in this case our relation is divides relation. So if x divides y and x is not equal to y, then we will draw the circle for x below the circle for y, and if y covers x, we will join these two by line segment. Y covers x means x is related to y, x is not equal to y, and there is no z in given set A such that x is related to z and z is related to y. Here our relation is divides relation. So x divides z and z divides y. Element y covers x if x is less than y, that is x related to y and x is not equal to y, and there does not exist any positive integer say z in given set A such that x divides z and z divides y. So this definition is very important, cover of an element in the drawing of hash diagram. That is the reason why I am repeating it in every lecture on hash diagram. Element y is a cover of x. If x is related to y, x is different from y, and there is no z in the given set such that x is related to z and z is related to y. So if y covers x, then we will join them by line segment. So first we have to decide that which elements are related to which elements and which elements cover the remaining elements. And here our relation is divisibility relation. Now we know that 1 divides 3 and 1 is not equal to 3, and there is no z in between 1 and 3 such that 1 divides z and z divides 3. There does not exist any positive integer z in given set A such that 1 divides z and z divides 3. Therefore 3 covers 1. If I talk about 1 and 9, then 9 is not a cover of 1 because there is 3 in set A such that 1 divides 3 and 3 divides 9. Here z is 3. So 9 does not cover 3 because there is an element 3 in a given set A such that 1 divides 3 and 3 divides 9. Therefore 9 does not cover 3. 3 is related to 9 and 3 is different from 9, but 9 is not a cover of 3. So we will not join 3 and 9 by line. So in this way we can decide covers of elements easily, and then we are able to draw the hash diagram. So here it is obvious that element 1 is covered by elements 3 and 5. So we have to draw the circles for 3 and 5 above the circle for element 1. Similarly, we can see that 3 is covered by 15 because 3 divides 15 and 3 is not equal to 15, and there is no integer z in between 3 and 15 such that this happens. So 15 will be a cover of 3. Similarly 9 will also be a cover of 3, and 15 will be a cover of 5 also, and 45 is going to be cover of 15 as well as 9. So let's try to draw the hash diagram for this partially ordered set. So first at the bottom we will consider this circle for element 1, and covers of 1 are 3 and 5. So let me represent them by circles which are above 1. So here 1 is covered by 3 and 5, so I am joining this by line segments. Now 9 and 15, if I consider 9, then 9 is a cover of 3, so I am joining them by line segment. And suppose I consider 15, then 15 is a cover of 5 also, and 15 is a cover of 3 also, and what is remaining? 45. So 45 is a cover of 9 and 15 also. So this is required hash diagram for this partial ordered set together with divides relation. Here 1 is below 3 and 5, and we have joined them by line segment because 3 and 5 covers 1. Similarly 9 covers 3, 15 covers 3, and 15 covers 5 also, and 9 is covered by 45. Similarly 15 is covered by 45. So this is for part A. For part B we have to consider m equal to 210. So first I have to write down the divisors of 210. M is 210, and in set A I have to write down the divisors of 210. So we can write 210 as 21 into 10. So we obtain two divisors, 10 and 21, then we can rewrite 21 as 7 into 3 and 10 as 5 and 2. So we obtain 5, 2, 3 and 7. Similarly, we can write this as 15 into 2. So we obtain 15 also. And if I combine 7 and 2, then I will have 14 into 15. So I obtain 14 also. And if I can rewrite this as 7 into 3, then into 10, so I obtain 70 also. Similarly, I can rewrite this, I can combine these two, so I will obtain 6 and into 7, so that is 42. And whatever is remaining, that I have to write down. So if we consider 14 is there, 15, 21, and suppose I combine these two, 5 and 7, then I will obtain 35. And 42 is also there, 70. And we can rewrite this 10 as 5 into 2, and if I combine 21 and 5, then I obtain 105, and 210 is always there. So these are the divisors of 210, and let me write them in increasing order: 1, 2, 3, then 5, and I have not combined these two. If I combine these two, 3 and 2, I will obtain 6 also. Then 7, 10 is there, 14, and 15 is also there, 21, and if we combine this 5 into 2, 10, and 10 into 3, 30. So I have to write 30 also if I combine this 3, or I can write 210 as 7 into 30. So I am writing 30 also. Then 35 is written, 42, 70 is there, and 105 and 210. So let me check how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. There are 16 divisors of the positive integer 210, and we have to draw the hash diagram for this set A together with divides relation. And we have to take care here, because we have 16 elements, so we have to represent them by 16 circles. Now first thing we will do is that 1 is at the bottom of the hash diagram, and which elements are covers of 1, that will be above 1. So it is obvious that 2, 3 and 5 will be covers of 1. 6 is not a cover of 1, because 1 divides 2 and 2 divides 6. So 6 is not a cover of 1. And if we consider 7, then 7 is a cover of 1. So we have this 2, 3, 5 and 7. These 4 elements are cover of 1. So we will join all these 4 elements to 1 by line segment, and circles for them are above the circle for 1. So let me write these elements: 2, 3, 5 and 7. And all these elements are not related to each other. 2 cannot divide 3, 3 cannot divide 5, and 5 cannot divide 7. And all these elements are covers of 1. So I have to join them by a line segment. So I join these two by line segment. There is a line segment between 1 and 3 also, line segment between 1 and 5, and 7 also covers 1. So I have to join these two by line segment. Now I have to decide the elements which are covers of 2, 3, 5 and 7 from the given set. So we can see this 6 is cover of 2 and 3, because 2 divides 6, 3 divides 6, and there is no z in between 2 and 6, and there is no z in between 3 and 6, such that this happens. This cannot happen because there is no z in given set such that these two happens. So 6 is a cover of 2 and 3. Similarly, we can see that this 14 is a cover of 14 cannot be a cover of 2, because 2 divides 7 and 7 divides 14. 10 is also not a cover of 2, because 2 divides 10 is a cover of 2 or not, that I have to check. But before that I have to check that. Okay, let me see whether 10 is a cover of 2 or not. So for that I require 2 divides 10. 2 is not equal to 10, and there is no z in between these two. So you can see 10 is also a cover of 2, because there is no integer in between 2 and okay, fine. So we consider 10 also as a cover of 2, and 10 will cover 5 also, because 5 divides 10 and there is no integer in between 5 and 10. What about 14? 14 is a cover of 2 or not? So 14 cannot cover 2. Okay, 14 is also a cover of 2, because 2 divides 14 and there is no integer in between 2 and 14. So I have to consider 14 also. And then what about 15? So 15 will be a cover of 3 as well as 5. 3 divides 15 and 5 divides 15, and there is no integer z in between 3 and 15 and 5 and 15. What about 21? So 21 will be a cover of 7, because 7 divides 21, and it is going to be a cover of 3 also, because 3 divides 21 and there is no integer in between. 30 is not a cover of any of these integers. 13 cannot be a cover of 2, because there is 10 in between 30 and 2. Similarly, 30 cannot be a cover of 3. 30 cannot be a cover of 5 also, because there is a 10 in between 5 and 30, and 30 is going to be cover of 10. So that we will see after we draw the circles for those elements which are above these elements. I am first finding the elements which are covers of 2, 3, 5 and 7 only. So I will not concentrate on 30, because 30 is not a cover of 2, 3, 5 and 7. Now I check for 35. 35 is a cover of 5, because 5 divides 35 and 7 divides 35, and there is no integer in between. 42 cannot be cover of 2, because 2 divides 14 and 14 divides 42. Similarly, 42 is not a cover of 3, because 3 divides 21 and 21 divides 42. Similarly, you can check that these remaining integers cannot be covers of 2, 3, 5 and 7. So covers of 2, 3, 5 and 7 are 10, 14, 15 and 21 and 35. So we draw the circles for this 10, 14, 15, 21 and 35. 5 circles and 6 also. 6 circles. So I have to draw the circles for all them above the circles of 2, 3, 5 and 7. So let me write one circle for 6 then one circle for 10, then one circle for 14, another circle for 15, and 21, and circle for 35. And now we have to draw the line segments. 6 is a cover of 2 and 3 also, so I join this 6 and 3 by a line segment. 10 is a cover of 5, so I join these two by line segment. 10 covers 2 also, so I have to join here also. 14 is cover of 7, so let me write this, let me join 14 and 7. 14 is cover of 2 also, so I have to join these two. 15 is cover of 3 and 5, so let me join these two and these two. 21 is cover of 3 and 7. 35 is cover of 5 and 7. So each of these elements 6, 10, 14, 15, 21, 35 covers 2 elements. 6 covers 2 and 3, 10 covers 2 and 5, 14 covers 2 and 7, 15 covers 3 and 5, 21 covers 3 and 7, 35 covers 5 and 7. Now after this we have to find out those elements in given set which are covers of 6, 10, 14, 15, 21 and 35, and circles for those integers will be above the circles for these positive integers. So now we come to the next part. Let me change the color here. So now I have to go for 30. 30 is a cover of which integers? So we can see 10 divides 30. So 30 is a cover of 10. Similarly 6 divides 30 and there is no integer in between. So 30 is a cover of 6 also, and 15 also divides 30. So 30 is a cover of 6, 10 and 15, because 10 divides 30 and there is no integer z in between 10 and 30 such that this happens. Same thing for 6 and 15. Now what about 35? 35 we have already taken. What about 42? 42 is a cover of which integers? So we can see that 14 divides 42 and there is no positive integer in set A in between 14 and 42. So 14 is covered by 42. Similarly 21 is also covered by 42. There is no integer between 21 and 42. And what about 6? We know that 6 divides 42 and there is no integer between 6 and 42 such that 6 divides z and z divides 42. So 42 covers 3 elements, 6, 21 and 40. Similarly 30 covers 3 elements, 6, 15 and 10. And what about 70? So 70 is also a cover of 10. We can see that 70 is a cover of 10 because 10 divides 70 and there is no integer in between. Similarly 35 divides 70 and what about other integer? 35 and we know that 14 also divides 70. So there are 3 elements and 70 is cover of these 3 elements. And now we check for 105. So 105 is a cover of 15 and if we consider 105, that is 15 into 7. So I have to write this as 5 into 3 into 7. So 21 is also covered by 105, 15 and 21, and if we consider 5 into 7, 35, then 35 is also covered by 105. So you can notice here that all these elements 70, 105, 42 and 30 covers 3 elements, or each of these elements is a cover of 3 elements. So now we have to draw the circles for these elements above these circles. So I can write here circle for 30, then I can write circle for 42 somewhere here. Similarly, I can write circle for 70 somewhere here and circle for 105. And now I have to join them by line segments. So here I have written 30 covers 6, 10 and 15. So let me join this 6, 10 and 15 by line segment 2, 3, 0. So let me join this. Then 42 is a cover of 6, 21 and 14. So 6 is joined to 42, then 14 is also joined to 42 and 21 is covered by 42. 70 is a cover of 10. So let me join these two by line segment. Then 14 is also to be joined to 70 and 35. So I have to join 35 and 70. 105 covers 15, 21, 15, 21 and 35. So let me join them by this. Now if you notice that this 1 is covered by 2, 3, 5 and 7, or I can say that 2, 3, 5 and 7 are covers of only one element, that is 1. Then 6, 10, 14, 15 and 21, each of these integers are covers of two elements. You can notice here that 6 is a cover of 2 and 3, 10 is a cover of 2 and 5, 14 is a cover of 2 and 7, 15 is a cover of 3 and 5, 21 is a cover of 3 and 7. Similarly, each of these integers 30, 42, 70, 105 covers 3 elements. So you can understand here pattern. Now after this we have to write only one element is left, that is 210, and that 210 is a cover of all these 4 elements 30, 42, 70 and 105. Here above this I have to write down 210, and 210 is a cover of each of these elements 42, 70 and 105. That is 210 covers 4 elements. This 2, 3, 5, 7 covers 1 elements. This 6, 10, 14, 15, 21 covers 2 elements. This 30, 42, 70, 105 covers 3 elements, and 210 covers 4 elements. Now if you recall previous lecture in which we have drawn the hash diagram for this set. In previous lecture we have drawn the hash diagram for power set of A with inclusion relation which has 4 elements, and here also you can see that this empty set is covered by singleton sets. Then each of these sets AB, AC, AD, BC, BD, CD covers those sets having only one elements. Then this set ABC covers 3 elements AB, AC and BC. So each of these sets covers 3 elements, each of these sets covers 2 elements, and each of these sets covers only one element. And you can notice that this hash diagram and hash diagram which we have drawn in this lecture for m equal to 210 are exactly same. The only difference is here we have factors of 210, and in that case we had taken power set of A where A equal to ABCD. We have taken subsets of ABCD. So we are getting the same hash diagram for these two partially ordered set, power set of A with inclusion relation and set of factors of 210 with divides relation. So this is just for your understanding, and this is the hash diagram for power set of A, which is the set of factors of 210 with divides relation. And you can see it is interesting to draw the hash diagram. You all have to take care that circle below the x element is drawn below the y element if x is less than y, that is x less than or equal to y and x is not equal to y, and if y covers x, join these two by line segment. So this is all about this session. I hope you like it. Thanks for watching.